We are still into proving identities, and what I am doing is I am showing you the different ways to begin and construct a proof when you are proving identities. So in this video, I will show it to you how to prove an identity by using this. You will multiply the expression, or you will multiply the expression by another expression which is actually equivalent to 1. So example 3.37, proving identities by multiplying by an expression that is equal to 1. You would know what this means. So prove this. Prove that cosine divided by 1 minus sine of theta is equal to 1 plus sine of theta divided by cosine of theta. You begin your proof by writing the word proof. So cosine of theta divided by 1 minus sine of theta is equal to cosine of theta divided by 1 minus sine of theta times, now look at this, okay? So this is where multiplying by an expression equal to 1 will come in. Times, okay, so that is times 1 plus sine of theta divided by 1 plus sine of theta. Now take a look at that. You know what? When I was a student, I can remember my days really. Our teacher wrote the proof. And hey, where did this come from? Where did this come from? So it's like my teacher did some magic tricks. It's like he pulled out a basketball from his ears. And hey, how can anyone fit a basketball inside an ear? And so he pulled that basketball out of his ear. And so that was like what I saw. It was like performing magic. I didn't know where this one came from and why our teacher must do this. Why must he multiply this by this expression? Well, for 1, you know that this is equal to 1. Okay? This is just equal to 1. And so you are not changing this by multiplying it to 1. And you know what? One of the things that I discovered in understanding a proof, sometimes you would understand why this has to be done when the proof is already done. So you just have to watch me, okay? So stay there, watch and listen. Okay, so this one is equal to this. Well, at the first place, this one is just equal to 1. And so we shall do your multiplication. So this is equal to cosine of theta times 1 plus sine of theta divided by, you will multiply these two expressions. And guess what? It follows the pattern of a minus b times a plus b. And you know what this is equal to? This is equal to a squared minus b squared. And so here, what it means is you will just apply your special products or your special product on 1 minus sine of theta times 1 plus sine of theta. And that is just equal to 1 squared, which is just 1, minus the square of sine of theta. So where did this come from? This came from here, the application of your special product. Okay? And so this one is equal to cosine of theta. Okay, so I will not simplify this by distributing cosine of theta to these terms, and you will know why. Now, what is 1 minus the square of sine of theta? So that is one of your Pythagorean identity. Okay, so this means 1 minus sine or the square of sine of theta is equal to the square of cosine of theta. Where did that come from? It came from this. Okay, so this is your Pythagorean identity. So cosine of theta, look at that. Look at this. Cosine of theta divided by the square of cosine of theta. You know what's going to happen next, okay? 1 plus sine of theta divided by, so you are left with only cosine of theta. And so we are done here. We are done now. Okay, so we have shown that this is equal to this. And look at that. So this is what I'm telling you. My students, now that I teach trigonometry, when I proceed with the proof and got here, they will ask me questions. Hey, why did you do that? And the truth of the matter is, you will understand why that is part of the proof when the proof is done. Usually in a proof, your statements must logically follow from the earlier statement. It's like they must logically fit each other. And this one multiplying by this expression doesn't seem it's a logical step. But just like what I told you, sometimes in order to justify why you have to do this, you have to finish the proof first.